The first thing we did, we signed up WellPoint, which is the nation's largest insurance company. This was in September 2011. And we took on a goal to say within a year we'll put Watson into production. Now the reality is we had no idea how this machine worked because IBM Research, I mean all the brilliant people that are there, they went across the IBM candy store, picked out all the technologies from databases to content management to analytics to hardware and software, and assembled something that we first had to decompose to figure out how it worked. And that's when Rob High and team, Rob's an IBM fellow, it's the highest technical designation you can get in IBM, and he and I go back 15 years at least, 12, 14 years, way back. And I was delighted to have him on the team to start figuring out how do we, first of all, take the machine that was the size of about half this room and make it manageable. So within a year, Rob's team was able to get it reduced to one single server. Okay, and pound for pound, it was 240% faster than the system that played Jeopardy. So first we had to scale down. Then we had to make it smarter. Then we have to say we have to teach it a whole new domain that Watson doesn't understand. It's great for Wikipedia and general knowledge, but we decided to take the target of medicine for the reasons you heard there. Information is doubling, evidence-based medicine is going to be where the cost and the benefits will be. One of the things we realized as we reduced the size of Watson also from a technology perspective, the Jeopardy system was a question-answer system. What we needed was a conversation system. Because if you just ask a question and get an answer back like Siri, it's valuable, but it's not very valuable in a business context. How do you ask 4 or 5 questions in a row so that the computer remembers the system and the theme around which you're discussing? So we added a capability working with research and software group called Watson Paths and dialoguing capability, which we continue to add. The other part we realized is the Jeopardy system maximum was needed to take only 3 sentences of input. Again, pretty useless when it comes to business because a medical record could be 20 pages long. Right? So the system of Watson today can ingest up to 20 pages and read 20 pages and understand and comprehend it one time, 20 pages. Again, significant breakthrough from our software. When I couldn't tell, I'm incredibly proud of not just the sales and marketing team, but also our technical team for the breakthroughs they have done. So that was the second big breakthrough. The third breakthrough was in Jeopardy, you didn't have to really externalize the evidence. You just showed the bars, and that was it. One of the things that was obvious to me within the first month was that's not going to fly with a business user to build trust. They will need to know, a doctor will need to know, not just the 3 answers, maybe the 10 answers. And they will need to know why are you saying what you're saying. So we had to build a whole system to externalize the evidence that the answer was being generated from. And essentially what we were seeing is a new class of applications that I call as probabilistic applications that work like the human brain, which is based on some probability of sorts, versus deterministic applications that we use today. One of the examples I use, borrowed from Steve, were the notion of probabilistic and deterministic. If you ask a computer today, what is 2 plus 2? It will give you an answer 4. If you ask Watson, what is 2 plus 2? It will come back and say 4, 99+% confidence. And it will also say configuration of a car, 2 in the front, 2 in the back, because I read an automobile magazine article, so I'm 45% sure it could also be a configuration of a car. Or it can say it could be a configuration of a family, because I read the Journal of Psychotherapy and Human Sciences, and 2 parents and 2 children, mother, father, and children is also a definition of a family. So we're talking about a new class of apps, again, instead of giving you transaction-based numerical answers, is giving you probabilistic answers. So that's sort of on the technology side.
And we have settled on sort of 2 ways of thinking about the role of cognitive systems in a society. One is in the role of simulating human-like behavior with respect to our ability to the ability of the machine to understand humans, understand their language, understand their intent, understand what they're asking about, and to understand the literature that you might read from which we can find answers. That's one side. The second side is the role that computing systems play in assisting human cognition, extending human cognition. One of the things that I think I still find as a profound statement of the value that Watson brings to the table came from one of our early customers who had been playing with Watson. And he came back and he said, what's interesting and powerful to him about Watson wasn't just the fact that it was answering questions and doing so fast and repeatedly, but rather that in doing so allowed him to realize he was asking the wrong questions. that for an analyst, this is magic. For an analyst whose professional responsibility is to bring new insight to the table, and to be able to bring to their customers a point of view that perhaps hadn't been considered, to realize that there's other questions that they hadn't been thinking to ask, opens them up to the vast number of risks and opportunities that lay hidden out there in the knowledge that they hadn't been exploring. So the fact that we can bring a computing system that understands human language well enough to be able to understand the vast body of human knowledge and answer questions at a rate that opens the mind to other possibilities and other ideas and other points of view, I think is a profound statement of what cognitive systems should be about. So as we move forward, you heard the voices of the doctors as well, this is not about computing systems replacing human judgment or replacing human beings in sort of the things that we find uniquely human, but rather augmenting and extending that human experience in ways that allows the human being to solve problems in a bigger and better and a more important way.
Shows in a transparent way, first of all, looking at solutions you might not have thought of, and then understanding what the probability of success was so that you can feel more comfortable in dealing with that. The other thing, too, I would say is that in many domains, you think of rule-based systems, we have a lot of systems that are fairly deterministic, ERP systems, many systems like this, except that you then see in business actually, lots of times managers have to deal with exceptions. Exceptions that were not covered in the existing policies. So what is the answer? We're just going to write more and more policies. To your point, they're going to get drilled and so on. The ability to be able to look at all the evidence, surface some hypotheses that maybe the human agent, decision agent may not have thought of, giving the probabilities of success of a particular hypothesis working, and then giving that to the human agent. And I think what this does is it changes the way human decision makers can work by having this type of assist.